Okay, so the average ticket price is modeled with this relation, the cost, and t is in years, where t equals 0 means 1995. So this actually means 6, I'm changing this to fraction, 6 over 100, 27 over 100, t, and 536 over 100. So we can see that we can factor out, well, definitely 1 over 100. So let's see here. Well, 1 over 100. And we get 6t squared minus 27t plus 536. So these two have 3 in common. Now, is this divisible by 3? 5 plus 3 is 8. 8 plus 6 is 14. This is not divisible by 3. Okay, let's see if this is factorable. It's going to be pretty tough because this has a lot of possibilities. So let's break down 536. It's divisible by 2 definitely. So 2, 6, 8. Divisible by 2 again. 1, 3, 4. 2 again, and you get 6, 7. Okay, so how about 6, 1? Maybe 8 and 67. Oh, so this is positive. So they both have to be negative. So this is going to be too much, right? Okay, so I don't think this is actually factorable. Okay, and we can determine that by using the discriminant, which comes from the quadratic formula. So minus 27 square minus 4ac. If this is negative, it's not factorable. Okay, so minus 27. 4a is 6 here, and c is 536. So if this is bigger than this, in this case it's going to be, it's not factorable. Not only is it telling us that, if it's not factorable, that means this is a parabola that's lifted above the x-axis. So what that means is that we can't actually use the factoring method. Okay, we can't find two roots and then find the find two roots and then find the midpoint to get the vertex anymore here. So we have to use a technique called completing the square here. So let's factor out 6 first. Okay. And actually, yeah, let's factor out 6, and we get t squared. This is 27 over 6t. And of course, this is 536 over 6 then. And I'm just going to grab these two. This is reducible, by the way. It's going to be divide top and bottom by 3, and you get 9 over 2. Okay, I'm going to expand this one with this. Okay, so to give you 536 over 100. Okay. Okay, and then I'm going to try to complete this square. So what do I need, right, to get a perfect square here? Well, I need this divided by 2. So 9 over 4 times by 9 over 4. Then you can have 2 factors of 9 over 4 to add up to get this, which is 81 over 16. 81 over 16. That's what I need here. Okay, of course I can't just add stuff in. I'm going to subtract it right after. So really, I'm just adding a 0, a total of 0 here. Okay, and then I'm going to just expand this blue part out. Okay, and 81 over 16, and we're going to get a minus 6 times 100 times by 81 over 16, and you got to combine them with this 536 over 100. Okay, so 6 over 100. This becomes t minus 9 over 4 all squared. Okay, so I converted the t squared with the t term with just t. I shouldn't have square there. T minus 9 over 4. Okay, so this here, so I get this in decimal form. So the important thing here is that the location of the vertex, this is 4, so it's going to be 2 and 1 over 4. So 2.25 and 5.05625. This is the location of the vertex. And it's a parabola going upwards, so that's where the minimum occurs. So I just answered part D, okay? So now, once we answer part D, everything else is very easy to answer. So what were the prices, ticket price that was the lowest during the period? This is the lowest price. Okay, that's the minimum. That's the location of the vertex. This is the lowest price. And then what was the average price in 1998? Well, that's just simply for part B. Okay, it's just 0.06. You just plug in 1998. Oh, sorry, 1998. 1995 is 0, so 1998 is just 3. Okay. $5.09 in 1998. And what does the model predict ticket price will be in 2010? Okay, so this year is 2.25, so in 2010, it's going to be even higher, right? It's going to continue to rise after 2.25. So in terms of what it is, let's plug in 5. Right, it's 5 because 1985 represents 0. Rises to $5.51 in 2010.